Assalamualaikum warahmatullahi wabarakatuh. My name is Aino Patisha Dalina binti Muhammad Ali. My student ID is 2024249196. My groupmate and I will be presenting the result of an experiment titled linear motion. The objective of this experiment is to investigate the relationship between force, mass, and acceleration. This experiment is also conducted to determine the acceleration of an object under a varying force. Linear motion is a motion of straight line in one dimension. When the object travels or moves in a straight line, it will change the time. Newton's equation of motion that we'll use and apply is F equal to ma, which m is mass and F is force. When m2 is released, both objects will accelerate. The two masses will have acceleration a of the same magnitude. The force from the contact of the frictionless surface pushing up on m2 labeled T. The contact and the gravitational force cancel each other, meaning the total force acting on vertical direction on m2 is equal to 0.
Hi and Assalamualaikum. My name is Nurul Azmi Asmi. My ID is number 2024238578. So, to conduct this experiment, we need to use a treadmill, blower, pressure tube, gliders, flags, photo gates, masses, mesh hanger, string, and pulley.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najmuddin bin Muhammad Rosi and my ID number is 2024237982. And today I would like to share with you guys about the procedure for experiment 4. First thing first, we have to make sure that the line air track was assembled as in the lab manual as shown in figure 4.3. Then make sure that the pump was switched on and the air was allowed to flow through the track. Let it flow for several minutes. Next, make sure that the track was balanced by adjusting the screw on the leg of the track so that the glider remains stationary and did not glide to either end when let go. Once done, make sure that one hook was inserted at one end and a flag was placed on the top of the glider. Please make sure that the mass of the hanger and the mass of the glider were measured and recorded. Then the length of the flag must also be measured. After that, make sure that one end of the string was attached to the hanger and the other end of the glider. Mass of 20 gram must be placed on the hanger and another 80 gram were placed on the glider. The string was then put over the pulley. Next, make sure the glider was positioned exactly before the photo gate. Release the glider and record the time shown on the photo gate. For a secure measure, please make sure to avoid the masses from crashing to the floor and scattering. Cut the glider with the hand before the hanger reached the floor. This step was repeated 2 more times to obtain the time average value. The sorted mass on the glider was decreased by transferring a mass of 20 gram onto the hanger. And the last step is repeat the step 7 and 8 3 more times with 20 grams from the sort mass on the glider added to the hanger.
These are the results that we obtained from the experiment. For the length of flag S equals 0.1 plus minus 1 times 10 minus 4 meter, means of glider and flag M1 0.19984 plus minus 1 times 10 minus 5 kilogram, and lastly mass of hanger M2 equal to 0.01008 plus minus 1 times 10 minus 5 kilogram.
And for analysis for question 1, plot a graph of weight, force versus acceleration, and this is the graph that we obtain from our data. For question number 2, what does the graph tell us? Okay, from the graph we can show that force directly proportional to acceleration. This means that the more force they are acting on the weight make the acceleration of the object increase. This depending on the weight that are used. And furthermore, from the graph we can also calculate the centroid of the graph by adding all the y or x values and divide them by the total number of y or x value. And for this graph, we obtain that the central of x is 13.2 and the centroid of y is 0.69. For question number 3, determine the gradient of the graph. So, the gradient of the graph that we obtain is 0.0443. For question number 4 is calculate the uncertainties of the gradient. For the max gradient, we got the 0.05, and for the minimum gradient is 70 over 440. So if we want to calculate the uncertainty of the gradient, we just need the gradient for max minus by gradient of minimum and divide by half, and that's how we get our uncertainty of the gradient, which is 0.0057. For question number 5, briefly explain the relationship between the gradient from the graph and the total mass. For our knowledge, the mass influence the gradient of the graph. As the more masses are added, the acceleration increase. So the relationship between the total mass and the gradient m are directly proportional.
Next, let's move on to the discussion. First, we need to calculate the percentage difference between the gradient m and mt. What is the percent error in this experimental value? First, we need to find the mt value. Seeing the mt value for all the data is similar, that is the one calculation for percentage difference and percent error. So gradient m we got 0.0443 meter per second square. Okay, to find the percentage difference, we use this formula, which is modulus value 1 minus value 2 over in bracket value 1 plus value 2 over 2 times 100, and the final answer we got 149.97%. To find the percent error, we use the formula modulus value 1 minus value 2 over value 2 times 100, and we got 85.7%. Second, discuss the factors that have contributed to the errors in the experiment. There were several factors that have contributed to the errors in the experiment. First is random error, which may have occurred due to the slight inaccuracy when reading the result. Second is systematic error. We may have applied the wrong pressure to the air blower, resulting in variation between low and high pressure. This could cause friction because the glider might not be fully lifted by the air cushion, leading it to touch the air track surface and create friction. Third, explain how to overcome the factors mentioned in question 2. To overcome the factors mentioned in question 2, we must make sure the reading is read correctly. We can repeat to read the results several times. Furthermore, we need to do the experiment correctly so we can get accurate data.
In conclusion, this experiment illustrates the operation of Newton's second law of motion using a linear air track. According to this experiment, the mass that we add to raise the overall tension is what has an impact on the acceleration. In other words, as more mass is added, the overall rate of acceleration also rises. In addition, to prevent data errors, all information was collected continuously and properly. That's all from us. Thank you very much.
Assalamualaikum and good evening to Madam Zubainun. My name is Nur Shasha Idina binti Muhammad Azad. Student ID 2024-289874 will now continue our group's next presentation, Experiment 5, Frictional Force. The objective of this experiment is to determine the coefficient of static friction of different surfaces. Next, let me introduce this experiment. Frictional force is the force that resists an object's motion on a surface, and it occurs when two surfaces are in contact and slide against each other. Friction are mainly divided into two types, static and kinetic friction. Static friction is a friction that acts on an object at rest in order to move the static object. Kinetic friction, on the other hand, is the friction that acts on a moving object. But in this experiment, frictional force between wooden block and rubber surface on a horizontal inclined plane is measured. Thus, by plotting the data, static friction can be obtained. Here is the list of apparatus used in this experiment. First, wooden block, that is rubber covered on one side, 50 gram masses, 10 Newton spring scale, string and tabletop. Next is the procedure or sequence of this experiment. Firstly, the mass of wooden block is measured and recorded as m. Secondly, the apparatus was set up as shown in figure 5.2. Third, the tabletop was made sure stable and horizontal to the ground. Fourth, the spring scale and the wooden block was attached with a string. It is then placed horizontally on the tabletop. The rubber side of the block was made sure to face downward. Fifth, M equals to 50 gram mass was placed on the wooden block. 6. The spring was pulled slowly, and once the block started to move, the spring scale reading was recorded. The value of static friction force was recorded and tabulated in table 5.1. 7. Step 4 until 5 was repeated. 8. Another 50 gram mass was added on the wooden block, and step 5 to 6 was repeated. The step was repeated until a total of M equals to 500 gram mass is on the wooden block. Lastly, step 1 until 8 was repeated, with the rubber side of the block being made sure to face upward. Now let's take a look at the results. This is the data and the result that we collected from the experiment. Mass of wooden block with rubber surface M is equal to 81.92 plus minus 0.01 gram. Moving on, this is the analysis of the experiment. Number 1. Draw and label the free body diagram of the wooden block. The forces acting on the wooden block is upwards normal force, downwards gravitational force, applied force is to the right, frictional force is the opposing motion. In the next part of the analysis, we have to plot graph of static friction force against normal force for the rubber surface and non-rubber surface. As you can see, in the center, we have the graph of static friction force against normal force for the rubber surface. And this is the graph of static friction force against normal force for non-rubber surface. On to the following section of the analysis. Use the gradients obtained from the graph to calculate the coefficient of static friction for each surfaces. As you can see, from our calculations, we obtained a result which is 1.26 for the coefficient of static friction for a rubber surface and 1.18 of the coefficient of static friction for non-rubber surface. Now, last but not least, compare and discuss the coefficient of static friction obtained. The coefficient of the static friction obtained for wooden block with a rubber surface towards the floor is 1.26, which is greater than the wooden block with non-rubber surface towards the floor, which is 1.18. A high coefficient of friction means that more frictional force is present relative to normal force. Therefore, this means that the wooden block without rubber surface needs less force to move the wooden block compared to the wooden block with rubber surface.
My name is Ain Zulaika bint Aidin, student ID 2024236834. So I'm going to do the questions part. So number one, how can anti-lock brakes stop a car in shorter distance than regular brakes? Anti-lock brakes regulates brake pressure and sensors are used to detect wheel motion and does not allow wheels to lose track. Hence, the car will stop at a shorter distance and potential accident can be prevented. So next, question number two. From your experiment, which material has the highest coefficient of static force? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? Okay, so the answer is the material that has the highest coefficient of static friction is the rubber surface. Yes, this agrees with our hypothesis. If we add more mass to the wooden block and slide it across a rubbery surface, then the force of friction will increase because when the object gains more masses, more force is needed to pull the object, causing the friction force that acting on the object also increasing. So, the last question is, once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. So, the answer, once the mass begins to slide, the rubber surface which facing the floor is undergo stop and go motion because of the coefficient of static friction force is the highest. Meanwhile, the non-rubber surface which facing the floor moves smoothly as the coefficient of static friction force is the lowest. So, in conclusion, by examining the relationship between static friction force and normal force, the experiment was able to calculate the coefficient of static friction for various surfaces. The findings showed that the rough rubber surface had a larger coefficient of static friction than the smooth wooden surface, indicating significant differences between the two surfaces. This result highlights how material characteristics affect frictional interactions. The forces needed to overcome static friction were clearly shown by the proportional relationship between applied force and the start of motion that was seen. In addition to providing students with theoretical and practical knowledge relevant to scientific and engineering contexts, these findings enhance their comprehension of frictional forces. That's all from us. Thank you.